Hello everyone, welcome to my YouTube channel. Welcome to the lecture number 2 of the basic econometrics lecture series. So in my last video I discussed about what are the dependent variables and dependent variables in a regression equation, and then I used the Gretl software in order to run the OLS model over there. So in today's video I'll discuss about the p-value interpretation of results, what is R square, and I discussed the regression coefficients, how to interpret the regression coefficients in my last video. In my today's video I'll discuss the p-value of the regression coefficients. So how can you say that according to the p-value your regression coefficient statistically significant or not, and then about the p-value of the f-test, and then also about the R square. So these three things I'll discuss today and with the help of the Gretl software. Okay, so today we will discuss that how can we tell that the regression coefficients are statistically significant. So starting again with the equation, y is equal to alpha plus beta x plus your error term. So in my last lecture I mentioned what is independent variable independent. So again, y is your dependent variable, x is your independent variable, or we can call it explanative variable, and beta tells you about the change in your dependent variable due to 1 unit increase in your independent variable. And error term, or we can say if you are taking the sample, we call it residual. So it tells you the difference between the original one and the estimated value. So basically it contains all the factors, other factors which affects your dependent variable, and which are not included in your model. Like they are not, it is not in error term, it will contain all the variables other than your independent variable. And if you have more than one variable like x1 or x2, so that will be your multiple regression. Now in my last lecture I discussed, and through the Gretl software I also showed you that how we interpret the beta, in which my dependent variable was GDP, and I wanted to see the effect of population and unemployment on GDP. So in that I just mentioned what was the beta and how can we interpret the beta value. In this lecture through the Gretl software again I'll tell you that how can we tell that whether the beta, these regression coefficients are statistically significant or not. Like if we see the p-value, so at a low p-value, a p-value of less than 0.05, we reject our null hypothesis. So first of all, what is the null hypothesis here? Null hypothesis is what usually the researchers do not expect that this will happen. So here when we are seeing the regression coefficients, the null hypothesis is that beta is 0, which means that it has no effect on your dependent variable like population. If I was taking the population, so it has no effect on the GDP. So when p-value will come less than 0.05, I can reject the null hypothesis that beta is 0, and I can say that whatever the value of beta is, it is statistically significant in explaining the dependent variable. So this is how. Now I also show you with the help of the Gretl software again. Now if you have if I take the f-test, so f-test is for the overall significance of the model. So overall significance of the model, again, if the p-value is less than the 0.05, we reject the null hypothesis. Now in this case, first of all, again, when you are looking at the f-test, overall significance of the model, so what is the f-test, what is the null hypothesis? It says that this model and your own model are same, like the intercept model and your model both have the same fit. So this is the null hypothesis. So when you reject, when the when the value of the p-value of f test is less than 0.05, you reject the null hypothesis, which is that both the model have the same fit, and you say that your model is better. Your model is better than the intercept model, in which just intercept term is included. That means that your model, maybe they are containing one very independent variable or more than one variable. So that basically it means that your model overall is just not telling about just one coefficient. It's telling you about that your overall your model is better than your intercept model. So f test tells you about the overall significance. So the p-value is how you interpret it. On the other hand, mentioning about the r square is from 0 to 100, and it tells you about the percentage of variations in your dependent variable due to your independent variables. So individually you can also check the regression coefficients, and overall r square will tell you the value that how much variations in your dependent variable is explained by your independent variables. And now there is a difference between r square and adjusted r square. If you increase the variables, independent variables, explanatory variables, or regressors, these are three names for the same thing. If you increase the independent variables in your model, your r square will increase, no matter if the independent variable is significant or is for the model or not, but r square will increase. So this is a problem with the r square. On the other hand, adjusted r square will only increase if you are adding an independent variable which is significant for the model. So this is the difference between r square and adjusted r square. So this is a very simple explanation of how to check whether they are statistically significant, what is r square, how you interpret the results. I'm not getting into the details of the mathematical derivations of the things, because the software will tell you about what is happening. And in my last lecture also I told you that we use OLS method, ordinary least square method. And why you use the ordinary least square method? Because it minimizes the difference between the square of the sum of the residuals. And what is your residuals? That your original value minus your estimated value. And you want it to be, of course you want it to be minimum. So basically, if you like, this is your error term is y original value minus your estimated value, and you want this error to be minimum. So through OLS you get the estimators. You are calculating these estimates, these beta values, and you want these estimates to be the best, to be as close to the original one. So that's why whenever you use the OLS, and there are certain assumptions which are linked with the OLS, which I will be telling you in each of my lecture, like multiconarity, autocorrelation, what are the tests for that. So in this this is the method we are using. And in the software, like I'm using the Gretl software, so OLS is given, you will just click it. And but why we use it? We want the best estimates, we want the sum of the square of the residuals to be minimum, and it has certain assumptions, and it has, for which we'll see that and that's why it is called the Gauss, according to Gauss-Markov theorem. If these assumptions, which I will explain, like multiconarity, autocorrelation, if all these assumptions are fulfilled, then we can say that our the estimators are blue, that is best linear unbiased. So in this way we want our estimators to be best blue and best linear unbiased, and that I will show you with the help of the Gretl software also. Okay, so now we will start with the Gretl software and see how we can interpret the things. So again, open data sample file, like I mentioned in my previous lecture. Okay, so this also we performed in our last lecture. Again, real GDP I'm taking as a dependent variable, unemployment and population I'm taking as independent variables. And now, okay, so in my last lecture I explained these coefficients, that what is the meaning of these coefficients. This tells you about the change in your dependent variable, that is real GDP, due to your unemployment and population. Now p-value, like I mentioned in my previous slide, that if it is less than 0.05, so in both the cases it is less than 0.05. So what does that mean? That we can reject the null hypothesis that unemployment and population has no effect on the real GDP, and this beta value, this regression coefficient of unemployment and population are statistically significant in explaining the variations in the real GDP. On the other hand, 97.6% of the variations are explained of real GDP is being explained by your unemployment and population. So and again, if you see the F test, the p value of the F test, these three things I mentioned today in my lecture. So I'm explaining all the things which I have mentioned today. So p value of F test is less than 0.05. So that means that overall the fit of your model is better than the intercept model, and you can reject the null hypothesis. And in the F test, as I mentioned, the null hypothesis is that in the intercept model and your model, they both have the same fit, yet they both. So if you when it is less than 0.7, you reject the null hypothesis that your model in which you have taken the two independent variables is better than your just intercept model. So both the variables are explaining the variations in your dependent variable. Now again, we can take some other data. So you can, from here you can go to the sample file, you can open any other data from here. For instance, if you want to see again model ordinary least square method, so OLS, this is ordinary least square method. I mentioned in my slide why you use it, and if there are certain assumptions associated with the OLS, which we will do in the next lecture, and if those assumptions are fulfilled, then we get the estimates which are blue, like best, linear, unbiased. So the model, in the model you just have to click ordinary least square and dependent variable. Square fit is your independent variable. Now again, you can see this p value, it is statistically, it is less than 0. Basically in the Gretl Software, if there are stars like this, so it shows you that it is statistically significant, but so it is less than, you can see that it is less than 0.05. So in this square fit, it is just showing you that with the change in your dependent variable price, with the change in the 1 unit increase, 1 square feet increase in the living area, how it affects your price. So it is basically said it is significant. 82% of the variations are explained by the by your independent variable, and then again adjusted R square is 80. I told you the difference between the adjusted R square and the R square. So 80%, according to the adjusted R square, 80% of the variations are explained by your independent variable. On the other hand, the p value of F test is again less than 0.05, which tells you that again you can reject the null hypothesis that the intercept model and your model have the same fit, and you can say that your model is better in explaining the variations in the dependent variable. So this is all about the things which we consider today. One more thing I just want to tell you, that in T ratio, how it is calculated, it is calculated by the coefficient over the standard error. If you divide 0.138 divided by 0.018, so that gives you the T ratio, and then you see the p value is less than 0.05, then you can reject the null hypothesis, as I mentioned in my slides and again in the software. So again, now we have seen a lot of things like R square and things. So you can also go to any of the files, and like I've also mentioned, this is a cross-section data and the time series. You should know the difference between the time series and the cross-section data, and even you can add your own data too. So again, in my next lecture, I'll be explaining that I'll be explaining the assumptions, and I will be explaining that how can you move towards like if there's what are the tests for the differences. So these are the basically different things that will be explained step by step. So here again, you from these three of the things, you can click on the Gretl green or this one, and you can, there are many things which are given over here. So this one, micro income, GNP policy deflator, gasoline price and consumption, and all these employment, houses, income, healthy, so gross income. So these are all the things, disposable income and consumption. So okay, if you just click that, and in the model, ordinary least square, again we know consumption is a function of income. So if you take the consumption as a dependent variable and you want to see how the independent variable income affects your dependent variable, so you can see here it means that it is given in the dollars. So it's given the per capita disposable personal income and personal consumption expenditure. So you can see that we 0.932, you can interpret it as with an increase in your, with the increase in $1, your consumption, with increase in the income, $1 increase in your income, your consumption will increase by 0.9, your consumption expenditure will increase by $0.93, and it is, this p value is less than 0.05, which means it is statistically significant in explaining the variations in your dependent variable. And we can say we are rejecting the null hypothesis that the income has no effect on the consumption. We reject that and we say no, it is the it has the whatever the coefficient is given, this is the effect, and it is statistically significant, explaining the variations. 99% of the variations are explained by your independent variable, and on the other hand, p value is also less than of f test is also less than 0.05. so overall it also tells you about the significance of your model. And so this is how sometimes it if you this you can see this if this summary output is given to you, then you can also you can also see which is a dependent variable. If I ask you that, well, how can you interpret this coefficient, or well, how can you interpret, so this is how just by one click you get the results, and it's as simple as that. How you interpret your observations, and interpret your observations, and then even if you want to add your own data, you can add your data in it, and that I will explain in some other video. So you can see that how it is so simple to use the Gretl software, and there are many sample files in the Gretl software. You can use it on your own, and you can just interpret the results. And so in my next videos, I'll also discuss the assumptions. Like I just told you that there are certain assumptions of the OLS model, and if they are not fulfilled, then there are certain tests for that, and then how can you detect that, and how can you, if there is a problem of like there's a problem of multicollinearity or autocorrelation, what you do. So in my next videos, I'll go towards these things. But there are many sample files in the Gretl software, so you can you can use any of the sample file. You can interpret the results, and if you have any question or any suggestion, you can give your feedback in the comment section. Thank you for watching the video. Hope you like that.